All right, Math Crew, as promised, here is the second half of that packet. I'll help you through a handful of problems. All right, so we left off on this page. This one you're just filling in, you're writing a rule for each table. So this is kind of working backwards. So you have to look at the input and the output. I'm not sure if they talked about those in the videos. I sure hope they did. I'm pretty sure they did. But X is always your input and Y is your output. You do not get an output without putting something in. So when you put in a 0, it spits out a 5. There's only one way to go from a 0 to a 5. If you cannot do that using multiplication, which means that our rule has to be addition. So what it says by write a rule is you're writing some sort of rule that relates y and x. Y equals something has to be happening to x. So when x is 0, y is 5. The only way to get that we talked about was through addition, so you would have to use a plus 5. So your rule for this one would be y equals x plus 5. And now we can test our rule by going back and plugging in each of the inputs. So this one definitely works. When I plug in 1 for x, when x is 1, 1 plus 5, y is 6. Good, that one checks out as well. Test one more point, always check 3. When x is 2, 2 plus 5, at y is 7, and that is also true. So we have 3 points that definitely works, which means our rule is proven to be a good rule. Next one, 12 to 4, there's 2 ways to get there, but again, we're going to start with our y equals something happening to x, y equals something happening to x. I'm going to do 2 because I told you there are 2 possible ways to get there. So the first way, how do I go from 12 to 4? I could try subtracting 8. That might work. The other way would be dividing x by 4 is actually a third. So dividing by 3. So those are the 2 ways to go from 12 to 4. So both of these rules currently work for this point, or this pair of x and y, this input-output. Now what we need to do is check a second point. So now when x is 18, y should be 6. Plug 18 into this rule. 18 minus 8 would give me 10, not 6. So that means this rule is no good. We have proven it wrong on that point. Now we hope it works for here, otherwise we've done something very, very wrong. 18, so when x is 18, 18 divided by 3, y is 6. So this point checks out. One more, 21. When x is 21 divided by 3, y is 7. That one works, which means this rule is good. All right, coming on back to number 6, we have when x is 0, y is 0. So right now, we have no idea, but they're definitely not adding or subtracting anything, so it's going to have to be a multiplying or dividing rule. Let's go to our second point. When x is 1, y is 3. Well, we know it's multiplying or dividing, so is this getting bigger or smaller? It's getting bigger, so that means this time we are using multiplication. So to go from 1 to 3, we would have to make it 3 times bigger. Let's double check this point works. Let's go back to the 0, 0. 3 times 0 is 0, which means this one also works. We have to check one more point. When x is 2, 2 times 3, y is 6. That rule is also good. Fantastic. Number 7. Moving on to number 7. I need to remember to scroll down. Sorry, guys. Number 7. The Gadget Factory sells Winky Diddles, whatever those are, in different quantities, as shown by the table. How much would 10 Winky Diddles cost? So it's asking you to do a couple different things. To figure out how many 10 are going to cost, we kind of need to know the rule, so that way we can plug 10 into it. So let's figure out the rule. How do I go from 7 to 24.5? Now, this could be an addition or a multiplication rule. So first, to go from 7 to 24, I know I would have to add, drawn a blank, 1750 to go from this to this amount. Now, if I add $17.50 to 12, is that going to give me 42? Absolutely not. So now I've proven that it's going to have to be a multiplication rule, so I can start trying to figure out what times 7 is going to get me to 24.5. The easiest way to figure that out is to set up a division problem, work backwards. So what times 7 gives me 24.5? Scroll over there. Just set up this division problem. 24.5 divided by 7 gives you your answer, 3.5. Now we can go back. I know that my rule, again, I knew it was multiplication, so it's going to be 3.5 times x, and that's going to spit out my answer every single time. Now that I've figured out my rule, I can use it to solve the question that they wanted. So now, how much would 10 Winky Diddles cost? So 10 is our number of Winky Diddles, so our input. So x equals 10, which means our equation looks like this. Y equals 3.5 times 10 instead of x, which is equal to 35. And then use a unit, which would be dollars. Okay, and that's how they wanted that problem solved. Next page. This one, you are just finishing the tables at the top. So in 1 through 4, you're just basically completing the tables. They give you the input, you run it through the rule. So when x is 2, 2 times 0, or sorry, when x is 0, 0 times 2 is 0, plus 4 is 4. You're just giving the output. When x is 1, 1 times 2 is 2, plus 4 is 6. When x is 2, 2 times 2 is 4, plus 4 is 8. And then when x is 3, 3 times 2 is 6, plus 4, y is 10. That's all you do to solve these. The rules can get a little bit trickier, but again, it's just computation, so you'll be fine. 1/3 times x is the same as saying divided by 3, but let's think about it as multiplication anyway. 0 times anything is going to be 0, plus 1 is 1. So when x is 0, your y is 1. Times 3, 1/3 times 3, well, 1/3 of 3 is 1, so 1 plus 1, your output would be 2. When x is 6, 6 times 1/3 is 2. 2 plus 1, your y is 3. See the pattern that they're going for? And that one, every time it increases 3 on top, it increases 1 on bottom. Alright, this one, I was going to help you, but now I'm not. Scrolling down to the very, very bottom question. It says, write a problem that can be represented by this equation, that one right there. So something equals 20 times an input plus 5. An example would be, those of you that are in this class, this math class will cost you $20 a day, so that's where this comes from. This is happening more than once. So $20 a day with an initial payment of $5 on day 1. So I will see that hopefully tomorrow, Monday. Just kidding. Next page, now we get to graphing. This is where algebra meets geometry, which is kind of awesome. So first, let's fill in the table using this equation that they've given us. So when x is 2, plug it in. 2 times 4 is 8, minus 8, y is 0. When x is 3, 3 times 4 is 12, minus 8 is 4. And when x is 4, 4 times 4 is 16, minus 8 is 8. Now it says to write the ordered pairs. And again, those are just x's and y's. So x is always first, 2. Now you see why we use the xy as our input-output. Y is 0. X is 3, y is 4. And then x is 4, y is 8. Now something amazing happens. You come over here and you have a coordinate plane that you can graph on. It's a little hard to see on my screen, but it's a lot more clear on your papers, thank goodness. They're counting by ones, so always start at the origin. When plotting 2, 0, you go over 2, up 0, so you have a point right there on the x-axis. Your next point, x is 3, 1, 2, 3 over from the origin, and up 4, 1, 2, 3, 4. And then when x is 4, 1, 2, 3, 4 away from the origin, y is 8, 1, 2, 3, 4, 5, 6, 7, 8. And then you can see these are starting to form a line if you have a straight edge, which I do not. I will use something. Let's try this other pencil. You can draw a nice, lovely straight line, and it should connect all of those points. And now your solution to this equation is that line, because that line now represents every possible answer that works for this equation. Moving on, it says graph y equals 6 minus 2x to the right. Use answers 2 through 4. All right, so it says at what point does the equation y equals that cross the y-axis? Well, I don't know, so let's create a nice t-chart like we had before, x and y. I like to use these 3 points always to start with, because 0 is a very easy number to work with. So when x is 0, 2 times 0 is 0, 6 minus 0 is 6. When x is 1, 1 times 2 is 2, 6 minus 2 is 4. And then when x is 2, 2 times 2 is 4, 6 minus 4 is 2. Now I've got something I can plot, so 0, x up 6. Right there. 1, so over 1 up 4. And then 2 over 2 up 2. And you can again see that every time it goes down 2 over 1, down 2 over 1, down 2 over 1. Now I have a cool, I'm going to freehand this one. Ooh, much worse. You guys should have rulers, but that's our line solution. So at what point does the equation cross the y-axis? Let's just go back to this lovely graph. This is our y-axis. This is where it hits it at 0.06. You also know that it's going to cross the y-axis when the x is 0. So if you just wanted to use algebra and not the picture, you could have just said, okay, well, I know it's going to cross when x is 0, so plug 0 into your equation, and you'll get 0, and it'll spit out the 6. If x is 2, luckily we solved that one, what is the value of y? 2. Our y over here is 2. And then last one, writing to explain, plot 0, 4 on the grid. So start at 0, go over 0, which is still on the y-axis, and up 4. Right there. On the grid, is 0, 4 a solution to this equation? Explain. For it to be a solution, like I said before, that point would have to be on this line. Because that point is not on the line, the answer is no, because it's not on the line. And this line represents all possible solutions for this equation right here. And that is the video. Hopefully it helps get you guys finished with this packet.